this trigonometric identity, you will see what we want to do. And again, there's a big difference between simplify and establish an identity, okay? So, good morning to everybody. Praise be the Lord. Now forever. Thank you. And here we're going to apply some principles, okay? The principle of the multiply by a well-chosen one, it's not going to be useful. And I'm talking about for the exercise we solved the last class, this one. This one will require something different, something new. It requires that we apply the algorithm of addition or subtraction with different denominator. If you don't remember or don't have clear what I'm talking about, here you have like the addition of two expressions, and if you see denominators they have are different. So practically what you have or what you will apply is next expression, which is called we call it like happy face method. And the idea of this is solve this type of expressions like quickly. Okay, so then you have a times d plus or minus addition or subtraction, b times c, and all that divided by b times d. Okay, so this is what we're going to use, and I think we're going to use it twice in this exercise. So please pay attention in all the details of the exercise, and I think you have to participate a lot. So please try to participate as much as you can. If you don't have an idea about what's happening, please make your question in the moment, and that way we're going to solve those exercises. So first thing we have to do, here's the expression. Again, the difference between a simplifying exercise like this one and an identity is that in an identity, we know what we want to reach. We know into what expression we want to convert that one. Right now, we're going to explore and see in what this becomes to be. I think at the end becomes to be just into a tiny expression, which will be related with secant or cosecant, I don't remember. But here we will see how to get that one. But the first thing we need to do, okay, having the exercise like it is 1 plus sine of x over sine of x is apply one of the techniques we already studied. Specifically, the first one. Who can remind me what is it? So what is that first technique that I explained you and it's going to be useful in here? Do you remember? So if you don't remember, here it is. There are 4 techniques that will be useful, and it's write everything in terms of sine and cosine, okay? And right now we're going to apply the third one, which is use sum or write sum of ratios or subtraction of ratios like one expression. That's what we want to do with this exercise. So the first thing, again, it's write everything in terms of sine and cosine, okay? So what things not in terms of sine and cosine? Can you tell me what is it? Because it's something that you can see right now in the whole exercise. You have sine, you have cosine, but there is one expression that's not in sine and cosine. We want to look for the way to convert it into sine and cosines. Which one is? Nobody see it?
Cotangent.
Yes, I'm agree with you.
What
is cotangent. Okay, so we're gonna concentrate in this one first. Yeah, I think you want to apply the technique of the happy face method here immediately. Yes, okay, but if we don't follow those steps that the same book recommend to reach at the beginning, then the exercise complicates a little bit. So that's why here I'm giving you the whole recommendations, the recommendations you will need in order to solve this type of exercises. So we want to change that expression, and we're not going to work with cotangent. we're gonna work with the expression that contains sine and cosine related with cotangent. I'm talking about this one, if you see. Okay, this is the one that works with sine and cosine and is cotangent at the same time. So cotangent is cosine of an angle over sine of an angle, and the rest, right? The rest of the expression. The rest of the expression we have, which is minus cosine of the angle, all that divided by cosine of the angle. So here you will see that many curious and interesting things will happen. But again, our objective will be join those expressions by the happy face method. But there's one observation here. Look, we're gonna apply this happy face method in this part over here, and we need to do it because that expression, like it is right now, it doesn't show us like something simple. Why? Because just here, just in this little part we have over there, and I'm talking about this one, the top one, we have a little exercise of the different denominators. Okay, so this is something we want to do every time. And if you have the option to apply first inside of a big exercise, this property, do it. Okay, so that's the recommendation for this type of exercise. We're gonna do it here with this tiny exercise, and then you will see how it works in the big exercise. Of course, we're gonna change this expression for the result we get in this one. Okay, so here we're gonna apply happy face method, and we're gonna multiply the cosine of x times 1, the sine of x times cosine of x, of course with a subtraction, and then sine times 1. So there is like the happy face, the happy face thing I told you that's gonna work in here. So this expression becomes to be cosine of x, all that times 1, minus sine of x times cosine of x, and all that divided by sine of x times 1. Sine of x times 1, yeah, will be sine of x. And the same is going to happen here. If you multiply this times 1, will be the same expression. So at the end, this expression becomes to be cosine of x minus sine of x times cosine of x and all that divided by 1 by sine. Okay, so exactly the same we did in here of the happy face method, the same we apply in here, will be useful for this exercise. Okay, so we're gonna concentrate over there. But the first thing we want to do is this expression we have over here, change it for what we discover it is. So here we go. It is 1 plus sine of x, all that divided by sine of x plus, okay, no more that expression. Now we're gonna work with cosine of x minus sine of x times cosine of x, all that divided by sine of x. Of course, all that expression at the beginning was divided by cosine of x. And now it looks like the exercise, instead of being simplified, becomes to be bigger. Okay, here comes the part that will help us to simplify a lot of the expression. And if you see, now because we have this addition, we have to join all those expressions. Probably someone is thinking into apply ER operation here, but if you do it like that, then the exercise becomes to be longer, okay? So we're gonna apply immediately what we have in here, which is the addition of these. And the reason is, if you see, when you multiply this times this, you're gonna join the two expressions, right? By the happy face method. You're gonna join just the two expressions. Nothing interesting is going to happen. But when you multiply these expressions times all that expression, what's going to happen with that sign? And what's going to happen with that sign? Can you tell me? Because here comes what I need that you do then. Analyze and predict what's going to happen if. So what happened if I multiply this sign of x times all that expression? Specifically, what's going to happen with this sign and this one? Can you see it? Can you predict what's going to happen? Nobody has an idea? Okay, let's see what's going to happen. Just let me conclude to show you how this is going to work. So there he is, and here we go. So multiplying those expressions, we got next. That right now doesn't look like we're simplifying it, but then you will see how this becomes to be simpler. 1 plus sine of the angle, all that multiplied by cosine of the angle, plus, because this is a plus over here, okay, plus, here is the part that I was saying, plus sine times cosine of the angle minus sine of the angle times cosine of the angle, all that divided by sine of the angle, sorry, I made the angle here, okay. Something will happen over there, all that over, okay, all that over, so I think that equal goes in here. All that over sine of the angle times cosine of the angle. If you have a question, do it right now. If something wasn't clear until here, do it right now. Say it right now. Nobody has a question? Okay. Look what happened, the thing that I was saying with the sine, this sine of x is divided by this sine of x, okay? And now the expression becomes to be a little bit simpler. Something else that you can do for next step is apply distributive property with this cosine of x. And you can multiply this cosine of x times each of these expressions. Sine of x times cosine of x is not an identity, it's not here. Sine of x times cosine of x doesn't exist. So we're gonna copy it like it is. I mean, we cannot do something else in here. It's like have x and y. I mean, if you multiply x and y, then you have the same expression, x and y. So here we go with this expression, and now it becomes to be a little bit simpler. Now here we have cosine of x times 1 is cosine of x. Then cosine of x plus, right? Plus, because of this plus. Plus cosine of x times sine of x is cosine of x times sine of x. Plus, and here comes the tricky part, plus the rest of this expression, which is just cosine of x minus sine of x times cosine of x. All that divided by sine times cosine. Okay, any question that you have until this step? Because now the exercise, it's everything in sine and cosines, okay? Something we should do is like identify like terms. In this expression on the top, if you see, when you have expressions like this one, what about if you have x plus xy plus x minus yx, for example, because it's essentially what you have in here. Do you have like terms here? Of course. This is x, and those yx expression, here is yx, I mean xy here, yx is the same at the end. All you have to do is switch the order. I'm saying this because something similar happens in here. And if you see, these expressions are behaving like this xy I present to you right now, okay? And they are like terms. So can we operate something here? Of course, many things. What do you think is going to happen with this cosine of x and these other cosine of x? With those cosine of x we have in here, what do you think is going to happen? It's the same that happens with this x and this x. What happened with this x and this x? They can be added, right? And the result is? Nobody? What is x plus x? It's 2x. Someone says, okay, someone says in the chat. Thank you. It's 2x. So someone says going to be cosine square. No, it's not gonna be cosine squared. It's gonna be 2 cosine. Okay, x plus x is 2x. I'm agree with you. Let's solve this part, and then the same is going to happen in this one. You will see. What happened now with positive xy with negative yx? At the end, yx is the same as xy. Okay, so what happened when you have positive expression and negative expression? It's like they cancel each other, right? So at the end, the result of this is 2x. The same expression or the same situations happen here. So those cancel each other. Yeah, I know here is cosine times sine, and here is sine times cosine, but it's the same. I mean, I have 2 times 3 is the same as 3 times 2. Okay, at the end, the result is going to be the same. Is that clear or not? Is that clear or not? Why I cancel those? I cancel those because one's positive and the other one's negative. You see, okay, one's positive and the other one's negative. That's why I cancel those two. And then, like you said, like you say it in the chat, but I think it's 2 cosine. It's twice this cosine of x. All that divided by sine of x times cosine of x. I'm gonna leave it until here in my case, and now I need your participations to conclude the exercise, because right now the exercise becomes to be easier. Now I think you feel that we already simplified that exercise that at the beginning has like an addition, and then you mix those addition in just one expression like this. So what else can we do in here? I need your participation, please, because here comes now your ideas. And of course, here comes many of the things we already did in other classes. So what else can we do in here? Or if you have a question, if not clear, how do I get that 2 cosine, for example? Is it clear? How do I get that 2 cosine? If it's not clear, look and check this one, okay? X plus xy plus x minus yx is the same as you have at the end, just 2x. So cosine plus cosine times sine plus cosine minus sine times cosine is the same as you have just 2 cosine. This cosine of x is behaving the same as this x in here. Why? Because we don't know the value of cosine of x, inclusively. We don't know the angle x. So that's why it behaves like that. So what is the next thing that we should do in this exercise now? Want to hear your idea. Can we do something over there, or that's all?
Mister, can you apply like yesterday the reciprocal thing in there?
Okay, but why you're gonna apply it? I mean, you don't have an addition, you have a multiplication over here. Yes, I mean, it's okay what you're saying. Thank you that you're giving me the ideas. Someone is saying that sine over cosine over sine is cotangent. Oh, you wanna convert this one in cotangent. It's okay. It's a good idea. You want to mix those and convert in cotangent, but then what you're going to do with this cosine below? I mean, there is something that you can do, and it's very obvious. What happens if you have 2x divided by, okay, someone already concluded. Not x.
We can leave it as cosine over sine.
You can leave it like cosine over sine. Okay, what you should do if you have an expression like that? I'm agree with what you're saying. Don't know how can you leave it just like cosine over sine. I mean, you want to mix those. If you want to mix those, yes, you can convert that one in cotangent. It's okay. And look, that's what I want. What happened if? I like that you're saying that you can combine those. And honestly, I didn't see it. That combining those, you can convert this one into cotangent. But my question is, what else can you do with this cosine below? Because you can do something. Someone in the chat already say it, but I want that some more students say it too. What can you do with this expression, for example? And remember that we are simplifying in here, right? I mean, what you said is true. Yeah, you can convert that one in cotangent, but then can be simplified more. I want that you give me the ideas. Okay, sir, if you want to unmute yourself and tell us why you conclude that, it's better. But again, I want that everybody see it. Excellent. Another student say, thank you, lady, you're totally right. You're saying cancel some expressions. Okay, that's why I'm showing you this example right now, because those skills you already win with the algebra are useful right now in this trigonometric topic, okay? What can you do with this expression was my question. Nobody tell me. I think that here, if you see that x up and that x down, it's repeated, so you can cancel those. So at the end, this is just 2 over y. And I'm saying this because 2 students already conclude the same. I'm agree with what you were saying. What happened if I combine those? Yes, it's true. Then this becomes to be 2 cotangent of the angle, but this still being over cosine. But this doesn't look like simplified at all. But if I do something else, and if I do something different, like you're suggesting to do right now, which is cancel this cosine and this cosine, like I did it with this exercise, okay? And that's why I'm saying many of the skills that you already know, that you already learned in mathematics will be useful right now. The exercise becomes to be simpler. Now you have now you have 2 over sine of x, which was simpler than have 2 cotangent of the angle over cosine of the angle. I'm agree with you that you can conclude things like this, but if you see, this one looks simpler. Inclusively, you don't have this expression here that's cotangent, right? You have it simpler, but you're still having something else in here, and I think that you can continue and conclude this exercise because here is hidden one trigonometric identity. And how do you know that? Okay, that's why you must have these identities in your hands, okay? These identities must be in your hands. Here is it's hidden one identity. If you're not clear how to get it, probably this property will help you. For example, suppose that you have, I don't know, 4x all that over 2. To simplify this expression, essentially what you did is you work with the numbers. So you separate your work, okay? You separate your work. And then you simplify this. 2 times x, which is just 2x. Essentially, that's what your brain do, and you solve those exercises very quickly because your brain already understands that you can divide those, okay? And essentially, you can divide some expressions in here. Just gonna give you like the tip, like the trick. The trick is, if you multiply this times 1, then you are in a situation like this one, okay? Not gonna say more, I want that you conclude it. Because here you can see, again, you can simplify more this expression. If you leave it like that, no. Not simplify it at all. It's okay, it's okay. Because you already joined the two ratios. But you have to conclude this expression until you cannot apply other property. So what idea do you have? What can you conclude about it? And here I need your participation. Still missing some minutes. Yeah, still missing some minutes. We have enough time. Nobody? Excellent. Someone already concluded. Thank you, sir. You're totally right. If you want, you can unmute yourself now and tell us what we should do. Because essentially, what I did in here will help you. I'm talking about this part. What I did in here, what I did with this exercise, sorry, what I did in here is useful. It's going to be useful, okay? If you don't see what I did, what I did is just separate this multiplication, this 4x, okay? This 4x into different fraction expressions. At the end, they are the same because you can join those by multiplying it like that. So then you have 4 times x is 4x, and 2 times 1 is 2. So this is what you want to do, okay? Essentially is this. You want to separate. Can you tell me how? Can you tell me how can you separate this expression? Of course, here you can conclude that this sign is multiplied by 1, 2, no problem. And this is not rationalization, okay? Do not get confused. It's not the rationalization. Because you didn't have like here plus something, no. That's when you have plus something, but in this case you didn't have it. So you can separate it like next. You can separate this like 2 over 1, which is just 2, times 1 over sine of x, which is one of the trigonometric identities that you have. And I'm saying this because this trick is the one that will help you a lot many times, because sometimes you don't fit the exercise like you want it. I mean, again, do you believe me if I said that this expression becomes to be 2 cosecant of the angle? If I ask you to convert this expression into 2 cosecant, it looks like it's impossible, but it's possible through all the procedure we have been doing it right now. So what is 1 over sine? Let's look in our identity table. Look for 1 over sine. Here it is. You already have it? Say it, please. There he is, 1 over sine. If you don't see it, pretty good. You must have your table. It's cosecant, okay? So that's why we can conclude that. It's so interesting, this topic of the identities, but again, you have to start making these questions to yourself. What happened if? What happened if? So then we have next. 2 over 1 is just 2 times 1 over sine, we said, is cosecant of the angle. And again, what I'm doing with these exercises is just showing you the tricks that then will be useful, or that will help you to create or to prove the identities, to establish the identities. So at the end, the simplification through all the procedure we did of this expression is just 2 cosecant, okay? I was reading something to make this easier for you, and other books suggest something else, but I don't know if you agree with this. Some books suggest to apply a trick which is called a change of variable. And for example, you can say that sine of x is just a. And you can say that cosine of x is just b. So instead of work with sine of x and cosine of x, you can work with a and b. So here is like 1 plus a over a plus, okay, cotangent is b over a. You have to write everything in terms of sine and cosine. Okay, that's the first rule every time. B over a minus b over b. Okay, but that's if you want, because then solve this type of expression, it's very easy. But I think it's better, because some books recommend to do that. It's better to understand the exercise like it is, okay? And that way, you're gonna conclude and you're gonna apply the properties that are needed, okay? So do you have any question? Because we are in the last minutes of the class, and I think these exercises are not complicated. Again, what I'm doing with this is just showing you the tricks, and I hope that you, I don't know, copy the tricks. Remember, next year in the university, sometimes teacher doesn't explain a lot. Just shows you one exercise and that's it, in the case of mathematics, not just in the case of mathematics, in the case of other classes too. Okay, I'm saying this because I'm looking this every time. So do you have any question? Something that wasn't clear at the beginning of the exercise? This is the whole exercise, if you see. So any question? If not, I think we can start leaving the classroom. And again, try to practice this exercise yourself. What do I need at the end? I need that you take those tricks, those techniques, because then you're gonna use it. So practice a happy face thing, because it's gonna be useful later. Practice, what else? Practice this thing of simplify when it's possible, because that helps you a lot to solve these type of exercises. Okay, guys, that's all for today, and I hope that you have your index card with you always with this topic, okay? So bye-bye and have a nice day. If there's no questions, no. Bye bye.